Okay, and so they all do what we call restoring the row graph properties. And the main thing there is that they may add edges. And they all abort if we would create a cycle. And we actually discussed conflict of interest, which other people call separation of duty. Now, the model that Sandhu and his colleagues came up with ended up being indistinguishable from the Nist model. And here is a fairly common representation of that model. So you can see it has all the same components, just drawn slightly differently. So we have roles, we have a role hierarchy. Permissions are represented by operations and objects together. And the new thing here is the fact that they have sessions. And sessions are there to represent the roles that a user has activated when they're actually logged in. And so the ANSI RBAC standard comes in 4 flavors. So there's what they call core RBAC, which has no role hierarchy. And I believe they left that in there because there are some commercial products that are like that, and they wanted the standard to apply to anything out there that was calling itself RBAC. Hierarchical RBAC has a role hierarchy. Constrained RBAC has separation of duty constraints, and then the 4th one has both hierarchical role hierarchy and constraints. The most common constraints that people talk about are static separation of duty, which applies to the user role assignment, and it says that when 2 roles are in static separation of duty relationship, that they should not appear in a single user's user role assignment. So the same user should never be able to use those 2 roles. Dynamic separation of duty applies to role activation. So you can have both roles in your user role assignment, you're just not allowed to activate them both at the same time. So this, they actually both talk about the role hierarchy because you're looking at the pairs of roles. So that's where those fit in. So the major differences between the 2 models, we didn't have sessions. They didn't have groups. And we had this thing called max role, which we were going to get rid of, and then we found a good use for it, which I'll show you in a few minutes. We have these side effects where we actually insert edges when we discover that the effective privileges of one role are a proper subset of those of another. We actually, so this implication is in both directions. We actually insert an edge. Whereas in the ANSI model, the implication is only in one direction, and you can actually have roles with equal privilege sets. Because they don't put in edges, it doesn't create cycles, right? Whereas for us, so they also require that their role hierarchies are acyclic. Okay, so with the ANSI model then, going back to the first example, the ANSI model actually wouldn't have a max role, so it would look like that. And the operations are in the given by the standard. You actually have to do 3 operations here. First you add the role, and then you add the 2 edges one at a time. And so you end up with this role hierarchy. And so we would have put an edge in here, right? So here's the contrast. We can say then that the ANSI model could be described as edges take precedence, whereas our model could be described as permissions take precedence. So
Sylvia, can I ask you a question?
Yeah.
So actually, it seems that I've found 2 different views of what roles are. So some people talk about functional roles, which are the one of the ANSI standard, but which those roles are the ones defined according to the functions of the organization. And so two different roles can have the same set of permissions without having any edge. Then there are people talking about application roles, which they refer to as a set of permissions.
Right.
So which one of the two semantics did you adopt in the RGM model?
So what are functional roles again?
Oh, those are the ones stated about the organizational structure of the organization, like a secretary.
And so you could have the same permissions.
Yeah.
And yeah.
Yeah.
In our case, I mean, if you really want two separate roles, you can put in a dummy permission to make them unique if you really want to. Yeah. The ANSI model also has these roles which have no additional permissions, but only users assigned to them. And again, we can't do this because we'd be obliged to put a cycle there. And so that's really how they deal with groups, and I think it's better to have the groups modeled with a separate structure. Okay, so just again then to show what can happen with only two operations. So if we take this top left ANSI diagram and add permissions 3 and 4 to the counselor role, we see they get propagated up the graph and nothing too exciting happens. On the role graph model side, we can't do that because the counselor role ends up with the same effective privileges as the instructor role, and we'd be obliged to draw a cycle. And so we would reject the addition. All right. Now, if we look at just inserting one of those two permissions into the counselor role, the role graph model can handle that, but then we discover that the financial aid role is a proper subset of it, so we draw that red edge in the bottom right of the picture. And I guess I should have deleted this edge here, but that's fine. And then what happens is, suppose I add another permission, say 12, to financial aid. Well, in the ANSI version, it's only going to be in the financial aid role and the admissions role, whereas over here it's going to be in all of these roles because they're all senior. And so in very few operations, the graph that you have, the role hierarchy, differs quite a lot. And my overall comment on it is I don't necessarily think one is better than the other. They're just different, and as long as you have good tools that give you feedback and you see what's going on, you can design the role hierarchy you want under either set of assumptions. So very early on, people were claiming that RBAC was general enough to simulate both mandatory access control and discretionary access control. Before you can talk about DAC, you need to talk about administrative roles, which I'll do in a minute. For MAC, the mapping is actually quite simple. If we have a lattice of security labels, which we have on the top left there, to simulate this with the liberal star property, which allows you to write up and read down, what you do is you reproduce the lattice with reading roles. You reproduce it upside down with writing roles, and then you put on constraints that says, say an M1 user comes along, when they try to activate any roles, they must have both M1 read and M1 write activated at the same time, and so that allows them to both read the low data and write the high data. Okay. For the strict star property, you just sort of create these little writing roles above each role. So the strict star property says if you're an M1 user, you can only write to M1, you can't write to any other levels. So if you're an M1 user on this role hierarchy, you'd be assigned to the M1 write role, which you inherit the M1 reading permissions and the low reading permissions. Okay. So those mappings are pretty simple. At around I don't know how long ago now it was, but anyway, for a while ago, I tried to look at converting from RBAC to MAC. So the idea I had was, well, suppose you have an RBAC system. Is there a way to test whether or not it's equivalent to some Mac system. And so what I did was